Yeah, welcome to the chemistry class. I will be talking on organic chemistry 2 as a topic. We've talked about organic chemistry 1 for some time now. We have various types of homologue. We have alkyne, alkanol, alkanone, alkanoate, and alkanoic acid. There are various families. We call them various families because they have different functional groups. What makes them to belong to that family? So there is a need for you to know. For instance, alkane has carbon-carbon single bond. Alkyne has carbon-carbon double bond. Alkane, has carbon-carbon double bond, while alkyne has carbon-carbon triple bond. Now, you must know that 4 bonds must join to a carbon atom. So, while writing alkyne, there must be a bond here, there must be a bond here. The functional group for alkanol is OH, and on and on. So, for today, we'll be discussing alkanoic acid. Alkanoic acid. It is written as RCOOH, where R is the alkyl group, and the alkyl, the general molecular formula for alkyl is CnH2n plus 1. The general molecular formula for alkyl is CnH2n plus 1. So I can just add this to it, and that gives me the general molecular formula. General molecular formula. There's a difference between general molecular formula and general formula. General formula is written as this, which I've written earlier. This is the general molecular formula. So you must not mistake the two. So I have some examples of alkanoic acid here. You have HCOOH. How do you name this? You name it based on the number of carbon atoms. You have 1 carbon atom here. And when you are naming, you make reference to alkane, which is the original homologue that we use to name after others. So since it has 1 carbon atom, and methane, which is written as CH4, has 1 carbon atom, this will be methanoic acid, because we are discussing alkanoic acid as the family name. So that's that. If you are told to write the molecular formula, this is how to write the molecular formula. CH2O2. Literally, what are we trying to do? How many carbon atoms do you have here? Just 1. That's what you have. How many hydrogen atoms do you have here? 2. That's the 2. How many oxygen atoms do you have here? 2. And that's it. So this is how to write the molecular formula. This, I meant the structural formula, whereby you depict it. I could have written it much clearly like this. For methanoic acid, HCOH. You can put a bond in between, and you may not. Where if you remove this hydrogen, what you have left becomes a functional group. And functional group determines the chemical properties of a compound. So this is how to write methanoic acid. Now when you look at this, how many carbon atoms do we have together here? We have 2 carbon atoms. Since we have 2 carbon atoms, and we remember that in alkane series, it is ethane that has 2 carbon atoms. So this will be called ethanoic acid. This will be called ethanoic acid. And you must follow this order while trying to write the structural formula. RCOOH, where R is the functional group. If you have a good understanding of organic chemistry 1, it should not be difficult for you to write all the alkyl groups. Like we have methyl. Okay, let me give you an idea. We have methyl, which is derived from methane. We have ethyl, derived from ethane. We have propyl. We have butyl. We have pentyl. Sorry, pentyl is C5H11, and on and on. So when you remove one hydrogen atom from alkane series, you have the alkyl. So this is methyl, this is ethyl, this is propyl, this is butyl, this is pentyl. Another idea you can use when you remember pentagon. Pentagon is 5-sided. So this is pentyl, it has 5 carbon. So that could also guide you in knowing how to write it. So coming back here again, I was trying to tell us how to, I gave a few examples how to write the molecular formula and trying to write the structural formula. I just wrote the structural formula for methanoic acid. So when you count this, you have 2 carbon atoms all together. Which alkane has 2 carbon atoms? That's ethane. So this is ethanoic acid. And how do you write the molecular formula? Count. How many carbons do you have all together? 1, 2. That's C2. How many hydrogen atoms do you have all together? 4. H4. How many oxygen all together? 2. O2. So that's how we have that. When you come here, you check again. Following this order, RCOOH. Your R, which is an alkyl, C2H5. You had your COOH. When you count, how many carbon atoms you have all together? That's 3. You have 2 plus 1, making 3. So you have 3 carbon atoms. How many hydrogen atoms you have all together? 5 plus 1, making 6. You have H6. How many oxygen all together? 2. So you have C3H6O2 as the molecular formula for, when you count, how many carbon atoms all together? 3. Propanoic acid, because it has 3 carbon atoms. Coming here, you have C3H7COOH. How many carbon atoms do you have all together here? This is 4. 3 plus 1 makes 4. So you have C4. How many hydrogen all together? 8. That's 8. How many oxygen? That's 2. So how would you name this? Following the few examples I've given you, just ask yourself, how many carbon atoms do we have? That's 4. Which alkane will have 4 carbon atoms? That's butane. Since we are discussing alcanoic acid as a family name, so this will be butanoic acid. So we can go on and talk about that. So now we have, when you look very closely, you realize that there is just one carboxylic acid here, which is written as COOH. So all these are examples of monohydric. All these are examples of monohydric alcanoic acid, whereby you have just one COOH. We have other examples of dicarboxylic acid, like ethane dioic acid. Ethane dioic acid will have 2 of this. It will have 2 of this. So that's a dicarboxylic acid. And we have another example of tricarboxylic acid, which is 2-hydroxypropane 1,2,3 tricarboxylic acid. Propane 2-hydroxypropane 1,2,3 tricarboxylic acid. That tells you that it has 3 carboxyl group. That's why it is 1, 2, 3. 1, 2, 3 tells you the position of where you have this. And from the functional group being COOH, you know is an alcanoic acid. Now we also have aromatic carboxylic acid. Aromatic carboxylic acid. So you could have something like this. like benzoic acid is an example of aromatic carboxylic acid. Benzoic acid, I'm sure you know this is how to write benzene, like hexagon. This diagram is incomplete. You either write it this way by just putting a circle inside to make it a complete diagram, or you draw the hexagon and you put your bonds where you should be. It could be double bond, single bond, double bond, single bond, double bond. So you can draw benzene this way or this way, where you have the double bond, this single bond, double bond, single bond, then double bond. So this is incomplete. I could even start my double bond from here. If you have been taught resonance in benzene, you will understand. So I could start my double bond from here. I started double bond from here while drawing benzene, but I could start it from here. So this will be double bond, single bond, double bond, single bond, double bond. So this is benzoic acid. And if I don't want to put the double bond, I could just cancel the double bond and just put my cycle there. So that's an example of aromatic carboxylic acid. There are some other examples, but I don't want to talk too much on that. Let's quickly look at some general properties. The lower members of alcanoic acids, they are colorless liquids at room temperature. Their boiling points are much higher than expected when compared with their molecular sizes. This is due to the presence of hydrogen bonds. Hydrogen bonds that is binding the molecules together. So the presence of hydrogen bonds makes it difficult for them to quickly vaporize. So before you know it, they'll be having high boiling point than expected. Even though hydrogen bonds are weak bonds, but because you have so much of such hydrogen bonds in between these molecules, it will be difficult for them to break. So you need a higher temperature for it to break into vapor. Alcanoic acid can dissociate in aqueous solutions to produce hydrogen ions. Alcanoic acid can dissociate in aqueous solutions to produce hydrogen ions. So you could have ethanoic acid, for instance, dissociating, being a weak acid, dissociating to give you CH3COO minus, dissociating to give you CH3COO minus plus hydrogen ion. So this is hydrogen ion, this is ethanoate ion, derived from ethanoic acid. You realize that this has 2 carbon atoms. So because it has 2 carbon atoms, that is ethanoic acid, which conforms to, this is an alkyl, that's R, then you have your COOH. You have your RCOOH, which is the general formula for alcanoic acid, as you can see on the board. So if this dissociates, it will give you 1 mole of hydrogen ion. So you could be asked, what is the basicity of ethanoic acid, for instance? The basicity of ethanoic acid is 1, or you can say monobasic, meaning it has 1 replaceable hydrogen ion in 1 molecule of the acid. Now we can have ethane dioic acid. You know, I told you there are some compounds that are having more than 1 functional group. So ethane dioic acid is written as, it's a simple way of writing it. You can write it this way. This is ethane dioic acid. And when it dissociates, It's going to give you something like this. In this case, you realize that it has two replaceable hydrogen ions. So this is dibasic.